As promised, we're going to not take any more notes on this page. We're really finished with it, but I want to just refer to it again as we move on to our next topic. This is a Michaelis-Menten plot, and I told you it's very valuable because we can take this hyperbolic curve and determine the Vmax and the Km. And if we convert the Vmax to a Kcat, then we can really discover really useful things about the speed of the chemistry of this reaction and the tightness of binding of the substrate and the enzyme. Now, in order to move on though, I have to point out to you that this is a hyperbola, and that makes it hard to work with. The Michaelis-Menten plot tangents out at Vmax, but we said it never really gets to Vmax. So the best we can do to determine Vmax is do an estimation of where it levels off. And because we use Vmax, or half of Vmax, to determine Km, that has to be essentially a rough estimation as well. Now there's an old trick that people used, and it's still in use today, and it's used in our lab, so I want you to be familiar with it. And it starts with the Michaelis-Menten equation. This equation over here, which is the y value of VO and the x-axis value of S, is going to be the definition of a hyperbola. And that's the origin of our problem. So let's move on to the next page and talk about how we can deal with that. So here, again, is the Michaelis-Menten equation, and it is a hyperbola. And what we are going to do is we are going to flip both sides of this. In mathematical terms, we are taking the reciprocal of both sides. Now, I don't really expect you to do this derivation, but notice that if we take the reciprocal of the left side, velocity, we end up with 1 over velocity, or 1 over v sub naught. And if we do the other side and do some rearrangements, we end up with what we call a double reciprocal. Now, let me tell you what we're going to do with that double reciprocal equation. What we want to do is, instead of plotting like we did before, velocity versus substrate, we are going to do a double reciprocal plot. And that is going to be 1 over V naught as a function of 1 over substrate concentration. Now, if that's the case, then this value is y, 1 over V naught, and this value is x, and what we have here is Km over V max. That is a combination of two constants. And we have plus 1 over V max. That's essentially the reverse or inverse of a constant. And I hope you can see what we have here. We have the equation y equals mx plus b, and that is a straight line. Now, let me make sure you understand. We are going to take the same data that we had collected on the previous page and plotted out in a hyperbolic form. And if we plug those numbers into our calculator and invert them all, it's the same data. That data is going to look like this. It's going to be a straight line, and it's going to have a positive slope like this. And what we do with that is actually draw a straight line through it. And I want that straight line to go through both axes. So the data is out here, but we're going to draw a line that goes straight through the y-axis and straight through the x-axis. Now, if you look at this equation up here, y equals mx plus b, remember what b is in a straight line? It's the y-intercept. And what that means is the y-intercept is going to be defined as 1 over Vmax. And oddly enough, the x-intercept, it's not as obvious from our equation as the other one, but the x-intercept is also equal to something useful, and that is negative 1 over Km. So if we do a double reciprocal plot, or what we call a Lineweaver Burke plot, that's named after the folks who first came up with this technique, we can take a hyperbolic data that's hard to estimate the Vmax and Km for, and we get a straight line. We can literally use a straight edge ruler, draw it down through the y-axis all the way to the x-axis, estimate the intercepts, and use these equations or these equivalencies to determine the Vmax and the Km. Now I'd like to practice this a little bit because this is a hard skill for students to determine, and a little practice will make it much easier. Before we do that, I want to point out the units on this Lineweaver Burke plot. Velocity units are micromole per second. Inverse velocity units are therefore, oddly enough, seconds per micromole. Substrate concentration units are micromolar, so inverse substrate concentration units are inverse micromolar. Those are nonsensical units, but because we flipped the data upside down, we've had to flip the units as well. That'll come in handy on the next page. Now I'm going to go not to your notes, because these aren't in your notes, but you can just look at this example of a Lineweaver Burke plot on the next page. What I'd like you to do is use your notes to determine what are the Km and Vmax. See if you can figure it out mathematically. And if you struggle with it, don't worry, we'll come back and give you a hint and show you how to do it. So pause for a moment, give it a try. Okay, now, anytime we see a Lineweaver Burke plot, and we know that because it's got inverse velocity as a function of inverse substrate, then we go and figure out where the intercepts are. And the x-intercept, or sorry, the y-intercept in this case is going to be 0.01 seconds per micromole. That's the units I told you. And that is equal to 1 over Vmax. The x-intercept down here is equal to negative 0.1 inverse micromolar. Strange, but that's what it is. And that is equal to 1 over, or rather negative 1 over Km. So if we solve this up here, all we have to do is invert this to become Vmax, and we have to invert that. And so what is the answer in this case? Vmax is equal to the inverse of 0.01, and if you get your calculator out and do that, that's 100. And we also invert the units back to what they were originally, which in this case is micromole per second. What do we do down here for the x-intercept? Well, the negatives cancel out, and we can invert both sides, and we get Km is equal to the inverse of 0.1. And your calculator would tell you that that's 10, and we invert the units back, 10 micromolar. So it's very simple to use the intercepts to get your data for Vmax and Km. That's the Lineweaver Burke plot, and this will probably be used in lab, and we'll definitely use it in some of our homeworks as well.